And in today's video session we will discuss STL, and STL is the last topic of your unit 5 or part 5. And in this video session we will discuss what are the containers, different type of containers we can use in STL, what is vector, what is list, and later on we will also discuss maps and algorithm. Probably in the next lecture we will discuss maps and algorithm, but in today's video session we will cover what is STL, what are the different template classes, what is container, what are different types of containers, what is vectors and what kind of different operations we can perform over vectors, and the list. In today's video session we will cover all these four topics, and in next video session we will cover what is map and what kind of operations we can perform using map, and later on we will discuss algorithm. Okay, so without any further ado, let's start with today's video session. STL stands for standard template library, which is nothing but the collection of template classes. Soon we will discuss what is the main use of template classes, but as of now you just uh, have this clarity that template library is nothing but the combination or the collection of template classes. The STL is mainly divided into three subcategories or sub libraries. The first one would be the container. So the container is mainly responsible to how to store data in different forms, in different patterns, how we can store data in memory. So we can go for different types of organizations, organized methods where we can store data in different forms. Let's say we can store data in sequential way, we can store data in node by node, or maybe by using list. We can use data in key value pair. So we have different types of containers. For example, as you can see, in STL is divided into so many categories, where all these categories would contain, let's say the containers would come inside the container. Algorithm part would be something which we can apply over the containers. Let's say the procedures we can apply. Let's say if we have a list or a vector, if we want to sort and search an element over that container, then we have to go or apply algorithm. The iterator would be the last category in STL. Iterator is nothing but to access individual element from the container and then process it by applying algorithm. uh, we use iterator to accessing the container elements. STL, you can see, as you can see, we have to cover this list, vector, map and algorithm for our syllabus. But still we have some other containers as well. Let's say we can store data in stack container, tree container, set container and many others. But mainly we will focus on list, vector, map, algorithm. Algorithm is not a container. List, vector and map is a container. As you can see, the the STL libraries are divided into three categories. So a container type of libraries would be responsible for storing and organizing the data. The algorithm, then algorithm would come into the picture. Algorithm would be a kind of procedures or the processing algorithms which we can apply over the containers, different kind of containers. The iterator then would be the third category in STL. These are the functionalities provided in STL that you can access the element and then perform operation on individual element using algorithms. So without containers, algorithm and iterator, STL wouldn't be possible to perform any single operations. Okay, so for efficiently use of STL, we have to use container, algorithm and iterators effectively and efficiently. So as you can see, STL libraries are divided into so many other categories. but mainly these are three categories. Okay, and container is nothing but organized data where we can store the data. So whatever data structure we are going to discuss, which would be responsible for, or organizing the data into some kind of a structure, would come into container part. So the containers are, as I have mentioned, that anything which would hold the data, or organize the data into some structure, would be called as a container. So container library is a collection of classes uh, which would actually store the generic templates as well. If you remember that we have discussed generic templates, or what it means to have a generic template means the the generic class would work for all kind of data types. So generic functions, as I told you, that you can pass any data type into the generic function. So it is similar to the generic class template, means the class can work on any kind of data types. So it will behave accordingly. So you can store list. You can if we talk about list can store list can be created by integer. And, we can have the list of integers, we can have the list of strings. So it means during the creation of list we have to pass the data type. So because of having the generic class template, the list can be created for any kind of data type, possible data types. That is why it is called the generic classes template. So in containers, if we talk about simply one type of STL libraries, then containers would be of list type, vector type, stack type, tree type, of map type, and set type. But in our syllabus we will only have list, vector, and map. So we will discuss one by one. Let's start the containers first, and then we will discuss the algorithm and iterators. Okay, along the way we will be discussing iterators, because with the help of iterators we can access the element of containers. And at the end we will also explore this algorithm part, because having those element into memory and then accessing those element from the container, then we have to apply some procedure and some algorithms, or those iterative values. Let's say the searching and sorting we can apply. So we will look into that aspect. First, let's explore what is list. So what is list? List is nothing but list is actually based on nodes. Linked list, it is actually based on linked list, where one node is attached to the second node. Okay, and a little different from your array, because in array you can access the element from index, but in list you are not supposed to access the element from index. So let's say you are provided a pointer of the first element. Let's say this is the head pointer and this is the tail pointer. So you have to increase this pointer to come to this node. So this is one limitation, you can say. You have to traverse all the nodes in the list to reach to a particular node. Okay, so using the pointer you can reach to the list. Okay, so it means you have to access sequentially to access the element. But in case of array, as you can see, okay, as it can be seen, 0 1 something something, so you can access any of any index element. So if you provide array 3, it will return you this element. But in case of, let's say, 0 node, 1 node, 2 node, so if you provide list 2, it will not work like this. Then what is the use of list? If we can directly access the element in array, but we cannot access, the main use is if you have decided to provide the size of an array, let's say ARR6, and only you have used these spaces. Okay, and these two spaces would be empty. But in case of list, only you use space only when it is required. Okay, let's say you are storing characters, so the unused memory will not be occupied in list. So that is what I have written. In array it uses fixed size memory but used and unused space. Okay, because we have given the fixed size. But in case of list, okay, we only give the memory to the memory if the memory is provided, or the used memory. Okay, if we have used the memory, then only we will provide the memory, if because we are not giving the size. Okay, in case of array we have to give this size prior to this declaration, but in case of list or any kind of containers, we are not required to give the size. We can grow this list and vector according to the need or the time, so it will definitely save. And another aspect of using list over array, one thing is space, and second thing is predefined functions. So let's say if we want to sort the element from this array, we have to go with any kind of n square, let's say selection sort, bubble sort, to sort the element of your array. And more importantly, we have to write this code by ourselves. But in case of list, due to having predefined functions, let's say the list would have this sort function, so it will do the same job for you without writing the boilerplate code. Okay, so you don't need to write such codes because we have predefined functions. So if we compare array with list, then this space issue would be there if you go with array, and the second would be you wouldn't be able to use the predefined functions. In case of list, let's say you can apply this sort function, okay, over list, and it will sort the list for you. Okay, so according to the need, you can go with array or list. Okay, but in list you have to traverse element from by using pointer. So and how you get the pointer of this, if you simply use the iterator, I'll tell you how to use the iterator. Then our iterator will point to the very first element of your list, and then you can increase that iterator till you reach to the last element, because in list it would have begin and end function, which will give you the first node and the last node from the list. So I hope this is clear that by using list you can achieve the space. You would have less space complexity because you are providing the space to the used space only. And then you have predefined functions which are provided by the STL list container, which you can apply over the list. Okay, and it would be super easy for you to use those functions in containers provided by STL. As array is manually created, so there are many issues with array. Okay, but in some cases array is best over list or any type of STL containers. It depends on the situations or the kind of need you are in. Okay, so that's all what we have discussed over here. In vector, if you talk about vector, we will discuss about vector, but in vector you can access random elements. Okay, but in list, because why you can access random element in list, because vector is based on array with just one functionality of resizing. We will discuss in later on. Okay, but as of now, let's discuss the code of list. Okay, so in list, let's say, and how to create a list. As I told you, these are generic template class it would provide you, so you can provide any type of data type during the creation of these containers or any list, as you can see over here. So we have created a my list, and by using these parentheses you can even provide the elements in the list. So we have a list of 3 to 1, and the list name is my list. Okay, as I told you that you cannot access the index element like this. Okay, because this is the feature of array. Okay, it will grow over the period of time. As you can see, we have not provided the size of the list. Okay, which is fine. So in STL you are not always required to provide the size. Okay, as of now it is actually calculating the size is 3. Okay, but still, if you know the size, you are not supposed to access the element like this. In array it is possible. Then how to access the element? You have to create the iterator of that list. So to create the iterator, you have to use this generic template class list int, and then use the iterator using scope resolution operator, and it would be a pointer. So it would be a pointer of what? It would point to the first element of your list. So this my list begin, if you call this function, it would return you the address of first node in the list. So p would hold the address of first node. So if we increase this pointer to next, and it will traverse till you reach to the last node. And how to find the last node? Again, my list dot end function, if you apply this, it would return you the end node address. So till p is not equal to the last node, keep on traversing. And how to print the value? Simply write star or asterisk p, and it would give you the element in the list. So if I simply execute it, it would give you 3 2 1 as the element of the list. How to calculate the size of list? Simply calling the size function. So this is simply very simple to call the size function. Again, I told you this, if you have a list, you can apply the sort function on it, okay, which was not possible with array. We have to create the sort method according to our need, and efficiency, the kind of efficiency we want to use. We have to create this sort method by ourselves. But as because my list is the container in STL, or STL template class, so with that we can apply different functionality on these template classes. So my list would sort the element, and what we are doing over here is, again, we are printing the element from this approach. Here we are simply starting the iterator, uh, and we will go till the iterator wouldn't reach to the end, and we are increasing the iterator, and then we are printing the element. Not only sort, we can also reverse the list. So if we simply call this reverse function over that container list, then we can now if we print this my list, I have copy pasted the same code over here, so it will print you the list in reverse order. So now the list would be 1 2 3. So if I simply execute this code, okay, STL list a.out. So as you can see, uh, earlier we have used this pointer technique, okay, which is printing the element 3 to 1, okay. The size of the list would be 3. After sorting, the element would be 1 2 3. After reversing, the element would be 3 to 1 once again. And one more thing, you wouldn't be able to compile this code if you do not add this this keyword into your G++ command, okay. Because the thing is, STL was introduced after compiler 11.0 version, so you have to use the at least compiler of the version which you are using should be at least 11.0. So explicitly I've mentioned that you go with the latest update of 11.0. So you have to add this command with the G++ command and simply compile it. And as usual, we go with the say.out. It will execute your program. So I hope the list is clear, and when to use list and when not to use array. This thing should be clear, okay. Now let's come to the vector, okay. The same code I have copy pasted over here. I'll provide the PDF of this code as well, but I suggest you to not directly do not directly use this code, and create these functionality by yourself by looking at the lecture for reference, where you can use this code, okay. Let's come to the vector. So as I told you, that vector is also based on array, okay, but with two changes. The first is, you are not required to give the size at the start. So the very first thing, if you go with the vector container in STL, the size issue is not there. You don't need to give the size at the start. And the second thing is, if you want to increase the size at the runtime, which is possible. So during runtime, if you want to increase the size or decrease the size, which is possible both, you can do it at the runtime. So when to use vector? When you want to create little dynamic array. Okay, so array, the vector is nothing but a kind dynamic array. Okay, it is similar dynamic type of array where you can decide the size during the execution. Okay, so you are not what to say restricted to use the size or the same size all the time. You can improve it, you can decrease the size according to the time. um, Another thing that as you can see over here, if you create a vector of integer, again this is again a generic class, so you can provide any type. You can create a vector of a string type as well. So as we are creating integer type of vector, which is a, and as you can see, we are creating the vector b. Okay, and we can apply this technique. You can make equal to b equal to a, which is possible in vector with, but in not in array. So there are many functionalities that you are not supposed to apply on array, but with vector you can apply. Okay, the most important factor I would say would be this resizing thing, because you are not restricted to use the same number of elements. If you want to increase the number of elements in your vector, later on you realized, okay, I have used very few elements earlier, now I want to include 10 more elements, then go with the vector type. Okay, I'll explain these different functionalities you can apply on vectors through the code. Okay, and the code I'll be discussing, I have copy pasted over here as well. So let me come to the vector code, and these are very basic functionalities which we can apply on vector. So as you can see, in vector we have created an integer vector. We can create a string vector as well. The name of the vector is g1, and as you can see, we have not given any size as of now, which is the property of the STL container, that you are not supposed to or not required to, it is not mandatory to give the size of STL container. But later on we have realized, okay, we want to insert 5 element into this vector, so you have to insert the element by using pushback function. So in that we are going from 1 to 5, so it means the vector would hold the number from 1 2 3 4 5. Okay, again in vectors, okay, as also you can access the element from the vector, like we have done in list. So again in vector, it is you have this begin and end pointer, so you can call these functions begin and end to get the iterator for your first and last element. So as you can see, the I would hold the first element address of the first element in in I you can increase, and it will iterate till you reach to the end of your vector, and by this it will print all the element in the vector. So the element would be 1 2 3 4 5. uh, if you want to use if you don't want to use begin and end, it also provides you r begin and r end. So these are nothing but the reverse end and reverse beginning of your list. So if you want to use this r begin, it will start from the last element. If you want to use this r end, it will start from the very first element of your vector, because these pointers are in reverse orders. So if you want to use the reverse iterator, then you have to use the indexing or the pointer in a reverse order. So as you can see, if I simply get the r begin, it will start from end and it will go till r end would be the very first element of your vector. So if I print if the compiler would execute this code, it will print the element in the reverse order, because the beginning of your I would to say the beginning of your vector is from the last element. Then again we have the size function, which would return you 5. The capacity of vector is not 5, it is very large, because you are not required to fix the size of this vector at the starting. So the size would be very large. I'll show you the range, but it should be very large. The maximum capacity will be shown like how many elements your vector, the vector you have created, can store. We will see the maximum size as well. Um, the main thing of the very important thing about vector is you can resize. You can change the size of your vector after even declaring or inserting the element, which is the beauty of using vector, or the the most important functionality of vector, that you can resize the vector. So now the fifth element will be dropped because you are using the you have resized it to 4. It means it doesn't it would lose the last element because the earlier the size was 5. So there is another again we are checking the size of the vector. There is another function which is which would return empty function, which would return either the true or false. So empty would return false when the vector is not empty. So if it is empty, it would return true. Okay, so in that case the vector would be empty if it would be true. Again, after resizing, we are printing the element, so the element would be 1 2 3 4. So without any further ado, let me execute it. So again, I have used this std equal to c++11. So make sure that you would use it, otherwise you wouldn't be as you can see. Let's focus on the output first. So we have 5 elements in the reverse order. We have printed 5 4 3 2 1. The size is 5. The capacity, one thing is I've mentioned that vector actually stores the element. It would provide you in one chunk it would provide you 8 element memory. So for 8 integers it would store for the first what to say, let's say if you have 7 element at the start and then you would add 2 more element. Initially it would provide at 8 element capacity, and then it would provide 8 more. For the ninth element, it would not provide just one memory, it would provide again the next capacity. So the capacity thing was different. Actually, I have mentioned that the maximum size, so the size vector can store would be based on the memory, the capacity of your memory. So the size, the maximum size would be very different. So earlier I have mentioned that to the capacity. So the capacity is different. Capacity is the memory chunk was provided by default for your storage every time. So the capacity is 8. For the next time it would be 16. 8 more did what to say, the integers, 8 more integers you can store in the next slot. So maximum size would be based on your the size of the memory. So that was by mistake I have mentioned this. For capacity is different. Capacity is 8. Okay, the default size provided by the compiler for your STL containers. Then the vector is not empty, and after resizing, the element would be 1 2 3 4, not 5. Okay, so after resizing, the element would be the updated element. So in today's videos I have copy pasted the similar code over here, so you can use this code as a reference. For today's video session, this is all. We have covered the overview of STL, the containers, different type of containers, what is vectors, and what kind of operations we can perform on vectors. Then we have used list, okay, and how and in which situation we go with list or vector over array. Okay, in the next video session we will discuss what are maps is another type of container, and algorithm is kind of process or the procedures we can apply over the containers we have learned. Okay, so this is all for today's lecture. So thank you so much guys, and have a good day.